intellectual property that has to be protected. So that cannot be put into the open source at this point. The community release will include most of the things that SAAS already has, and you will be able to install it as well. Because we do what we call topographical fraud analysis, we're able to analyze multiple locations at the same time. So it doesn't mean that if you have one PBX system, you need one platform. You can have one platform and manage multiple systems, and I'll show you in a minute how that works. The more people hook up into the SAAS, into the software as a service environment, we are able to detect things faster. We're able to go about and analyze more patterns. We're able to get more information. We've seen patterns of attacks, patterns of various fraud attacks being repeatedly done around the world. If it was done once in Israel, then I know for sure it will be done in the UK, and then somewhere else, and then somewhere else. All the entire system is completely secured and encrypted. No data, the service data, is available on the internet. There is no access to it directly. It is never hooked up directly to the internet. I'll show you how it's done. First community release, as I said, is due for 14th of November. Initially, we started as a service, not as an open source project. We were thinking mainly of doing a service. Then we realized that our force alone will not help, and we need additional people to help us. So that went into the open source and said, okay, let's do it like that. We are able to supply an API for third-party vendors of PBX systems. So if you're using, currently we support mainly Asterisk. This is the agent that we currently wrote. But if you're using FreeSwitch and you want to write your own agent, you can hook that one in. If you're using Avaya, Panasonic, and you've got access to their APIs or whatever they have, fine by us. It's fine. You just go about and send us the information through an HTTP request over an SSL link. That's not a problem. The connecting client that we've released is fully open source, so you can just download it when you sign up to the service. You can see that there's nothing malicious in there. It's very small. We currently correlate around 500,000 records every day. That's just inside the service, what people send us, what we manage to hook up. We're currently servicing PBX owners, a couple of tier 3 operators, and an MVNE. Now, if somebody doesn't know, anybody know what an MVNE is? Everybody know what an MVNO is? Okay, MVNO, Mobile Virtual Network Operator. In the US, they're very common. You may know them as Virgin Mobile, TracFone, all these low-cost mobile companies. And an MVNE is a Mobile Virtual Network Enabler. A company that enables people to build MVNOs. The architecture, as it is, we are using multiple servers around the world. We have, by the way, we also have our own network of Asterisk-based honeypots scattered around the world, which are, their purpose is to actually get people to try and hack them. Now, they are built out of different levels of hackability. Some are very, very simple, using, for example, old elastics and old tricks boxes that had various backdoors into them. And some of them are highly complex. AKA, if you manage to hack this, you're really good. We've got an API cluster. That means all the requests come into a load balanced set of servers inside our cloud. We've got an analytical cloud that crunches all the numbers and basically does all the analytics. Of course, a web GUI. Nobody can do anything without web GUI, right? And of course, the old dreaded database cluster that usually nobody knows how to handle. And I'm happy to say that we managed to go about and handle it quite nicely, especially with 500,000 records every day being added into the system and analyzed and being inflated to about 2 million records. Fraud facts. Just a bit of ideas to give you. Fraudsters are becoming more and more resourceful. Now, it's not, we're no longer in the days of Captain Crunch. Okay? Okay, everybody know who Captain Crunch is? Okay, well, anybody who's above the age of 36 may know who Captain Crunch is. Okay? Right. Okay, so the old days of phreaking with a PH and so on, they simply do not exist. The old 2600 tone no longer exists. But the thing is this. Hackers today are, not fraudsters today are perfect hackers. These guys, they employ real hackers. These guys are web hackers, core hackers, whatever you want. They know what they're doing. Fraudsters are caught when they become greedy. A good fraud will never get detected. Never. Ever. Why? I fear that if somebody makes a single phone call per day that is a fraud, then no, I will not be able. I may be able to go about an alert that it's something doesn't fit there, but it will not flag a red flag. What?
If it's the Mali on Yom Kippur.
Yeah, if it's the Mali on Yom Kippur, yeah, that will flag, boo, big time. Now this is something that is really, really problematic. Greed or plain capital shortage can turn an integrator into a fraudster. Now, this is something I know. I've been called in to investigate 6 different systems that got defrauded in a period of 22 hours. Each of these platforms got defrauded for approximately $20,000, more or less, 6 different systems, in the same 22 hours. And they all came from the same integrator, which was really weird to me. Really, really weird. And I started investigating, and they all had the same pattern. They were hacked exactly the same. They were same deployment, same usernames were used, same passwords were used. Everything was identical, up down to the no CDR and the context that was added. And that alerted me that something else is happening. So I actually said to myself, okay, there's something else going on here. So I started looking at the firewall. Eventually I found out in 3 different systems there was a checkpoint firewall in the front that was logging everything, which was really good. And the fact was that we identified that all SIP requests came from the same server of all 3 attacks. And they all belonged to a single location. Actually, in that specific case, it was a hosted server somewhere in the US, which was really problematic because I had to put a lot of strings to see who it belongs to. And we found it out, a big deal. Not very nice. In order for a fraud attack to be successful across the globe, it requires many resources from the frauder. Let's think about, for example, premium fraud or toll fraud or somebody doing arbitrage. For example, inbound call arbitrage on mobile networks. That means that if I'm doing it, I need to have a lot of mobile numbers scattered around the world in order to do it. That means that these hackers, these fraudsters, they have a lot of resources. They actually invest a lot of money in creating a really good scam. And sometimes it's not that easy to detect. Always expect fraud to originate from the least expected source. Really. Sometimes it comes from the... if you want, later on, after the talk, I'll tell you a story about fraud that happened 3 years ago that would leave you on the floor laughing. And you won't believe it. It's not really fraud, it's something else. But just a few facts about the service. Humbug is not a fail-to-ban system. We are a monitoring and alerting system. That means we will not have any control over IP tables or checkpoint firewalls or PICs or ASA or whatever at this point. And the main reason is that we're not yet at the point where we provide a 95% assurance of what we do. We're still in development. So once we reach that 95%, then maybe we'll add it, but not at this point. It is very complicated to identify small-scale fraud. However, when we utilize multiple sources at the same time, we are able to go about and detect different patterns. Again, most of the fraud that we've managed to find is toll fraud and long-distance fraud, and repetitive patterns always emerge. We'll let them finish. And this is nice. We trust no one. And when I say we trust no one, we actually had 2 fraudsters hook up their Asterisk systems into the service, trying to inject, to go about and enlarge the noise signal ratio to make us believe that normal traffic is to Mali or to other obscure locations. And the nice thing is that we're able to go about and detect that. And we just flag these as red systems, and we let them, okay, do whatever you want. You're just alerting us what you're doing. Fine. I have no problem with that. Just a bit about our roadmap, what we're planning. Again, the initial services that are currently available are mostly the Analytical Engine. There will be, as I said, a community release of the Analytical Engine within 2 weeks. We'll start to provide fraud analysis over the service, the SAAS, in Q2 2011. That will be available to all users initially. CP-based licensing for fraud analysis for people who decide to install the community edition and want to add fraud analysis. We'll get that around Q4 2011. And we are planning to have fraud insurance and to offer fraud insurance to users of the service somewhere around 2012. That's more or less. What I wanted to show right now is a small demo of actually how the system looks. What we tried to actually do is mimic the very much, let's say, de facto standard for web analytics system, which is Google Analytics, and we tried to give it a very much similar interface. What we actually see here on the screen is actually a fraud attack. This is a fraud attack from last week. It happened it was around 6 p.m. And these were calls to, I think, somewhere in Africa. But the nice thing is that the system actually was able to pick it up in about 15 minutes. The fraudster started making very short 15-second calls to the designated location, and the system alerted us within about 15 minutes of that specific anomaly. We were able to call the customer, and they're not paying yet, but I am calling them customers. We were able to call them up and say, we've detected something on your system, something is wrong on so-and-so specific server, because we are able to go about and analyze more than a single server, as you can see here. We can hook up multiple, what we call API keys here. So I can create, for example, a new name, for example, PBX Astricon.net, and I'll do save, and I'll get now I'll get an API key and an encryption key. These keys have to be put into the client when you install it on the actual Asterisk server. So whatever goes in from your system to ours is fully encrypted. With Asterisk, what we do is actually we connect to the Asterisk manager, and as it shoots out events, we go about and we analyze these events. Now, most people will say, sure, you analyze CDR events, then we do not analyze only CDRs. We analyze a lot more. For example, anybody know what a link event is, or an unlink event, or new extend? So, yes, we've been using Asterisk for a long time now, so we kind of are familiar with what the obscure Asterisk manager does. Another thing which is really nice is this. If you pay attention, and I guess most of you are familiar with CDR stats or CDR tool. Oh, what's the name? Now, it's a nice tool as long as your PBX doesn't have 2 million records. If you have 2 million CDRs, then it's a serious snooze. Just hit the snooze button and wake me up at some time because it will never finish working. If you notice, our interface works really fast. And there are right now, there are a few dozen million CDRs in there. How are we able to work this fast? Very simple. All the data that's being displayed is pre-crunched. Whatever is being displayed is being prepared for you, specifically for your user. There is almost no database interaction from the interface. That is one of the key features of the service. Another element is trunk stats, is you are able to go about and analyze traffic on specific trunks according to how the system you've basically taught it to understand what it sees. Another nice thing that people asked us to do is this, rates. it is also a radar.